We want to find the equation for the graph of the set of points whose distances from 5, 0 and negative 5, 0 always sum to 12. So by definition, this means our graph will be an ellipse, and 5, 0 and negative 5, 0, which are along the x-axis, are the two foci, and therefore we have a horizontal major axis. Let's go ahead and plot the two foci using this ellipse. So let's say this is one focus with coordinates 5, 0, and the other focus is here at negative 5, 0. Notice how the center of the ellipse is at the origin, this point here. Now looking at our notes, notice the distance from the center to one focus is equal to c units. So in this case, notice that c equals 5. Now because we have a horizontal major axis and a vertical minor axis, the equation of our ellipse will be in this form here, where the center is h, k, and notice how because a is greater than b, the larger denominator will be under the x part of the equation. If we had a vertical major axis, a squared, the larger denominator would be under the y part of the equation. So in order to find our equation, notice how we need to find a and b, where 2a is the length of the major axis, and 2b is the length of the minor axis. Now we're told our graph is a set of points whose distances from these 2 points always sums to 12, which means if we select any point on our ellipse, let's just say this point here, and find the distance to this focus, and then find the distance to this focus, the sum of the distances must be 12. So if we call this d sub 1 and d sub 2, for any point on the ellipse, d sub 1 plus d sub 2 equals 12. But d sub 1 plus d sub 2 always has the same length as the major axis, which is equal to 2a. So we can say that 2a equals 12. So if we divide both sides by 2, notice that a equals 6. So we still have to find b, but before we find b, let's try to explain why the sum of the distances would always be 2a. Instead of selecting this point here, let's say we selected the point to be one endpoint of the major axis, or here. Well, we know from our notes that this distance here, from the center to one endpoint, is equal to a. So notice how the distance from this point to this focus here would be a plus c. So we'd have the quantity a plus c plus the distance to this focus, which would be this long length a minus this length c. So plus the quantity a minus c must be equal to 12. Notice how here we have c plus negative c, which would be 0, giving us 2a equals 12, or a equals 6. So it is always true, the sum of these two distances is always equal to 2a, but hopefully this helps explain why. Now that we know a is 6 and c is 5, we still have to find b to find our equation. To do this, we can use the formula a squared equals b squared plus c squared. So if we know a squared equals b squared plus c squared, we would have the equation a squared, or 6 squared, equals b squared, the unknown, plus c squared, which would be 5 squared. So we have 36 equals b squared plus 25. We subtract 25 on both sides, we have b squared equals 11. So b would be equal to the square root of 11, but we don't need b to find our equation, we only need b squared. So now that we know b squared equals 11, we can find the equation of our ellipse. Remember, the center is at the origin, or the point 0, 0. So for our equation, we would just have x squared divided by a squared, where if a is 6, we have 6 squared of 36, plus, again, if k is 0, we have y squared, divided by b squared, which we just found to be 11, equals 1. This should be the equation of the ellipse that satisfies the given conditions. I hope you found this helpful.